A black hole is not a hole, it's a boundary, a place where the universe stops explaining itself. We call it the darkest object in existence, a cosmic destroyer, a final grave for matter and light. But this description is misleading, because nothing truly falls into a black hole the way we imagine falling. What disappears is not matter, it's the future. Cross an invisible line, and return is no longer part of reality. At the center of this collapse, physics predicts something extreme, a heart, a place where density becomes infinite and the equations stop working. Some call it absolute nothingness. Others suspect something far stranger, not an end, but a beginning hidden behind collapse. Tonight, we are not asking what a black hole destroys. We are asking what happens when reality itself can no longer explain what it contains. When we talk about the heart of a black hole, we imagine a center, a core, a place you could point to and say, there. But this is already a mistake, because a black hole is not an object sitting inside space. It is a distortion of space. There is no solid center you can approach, no surface to reach, no location that behaves like the inside of ordinary things. What we call the heart is not a place in the usual sense. It is a prediction, a signal that our descriptions of reality are breaking down. According to Einstein's equations, as matter collapses, density increases without limit. Space curves inward, time slows, then collapses with it. Eventually, the math reaches a point where values become infinite. This point is called a singularity. But a singularity is not a confirmed object. It is a warning. It marks the moment where the equations stop making sense. In physics, infinity does not mean we found something ultimate. It means the model failed. So when we ask what lies at the heart of a black hole, we are not asking about a thing. We are asking what remains of reality when our best descriptions can no longer describe it at all. Every black hole begins with a boundary, not a wall, not a surface, an invisible line in space called the event horizon. From the outside, nothing special appears to happen there. No brightness, no sudden force, no visible edge. But once this line is crossed, the structure of reality changes permanently. Escape is no longer a matter of speed. Not even light can return, because beyond the horizon, space itself is falling inward faster than anything can move outward. This is what makes the event horizon so difficult to understand. It is not something pulling you in. It is something removing all possible paths back. For a distant observer, objects falling toward the horizon appear to slow down. Time stretches. Signals fade. From their perspective, nothing ever fully crosses. Everything freezes at the edge, redshifting into darkness. But for the falling object, there is no pause, no moment of hesitation. Crossing the horizon feels ordinary. No alarm sounds. No barrier appears. The difference is not physical. It is perspectival. The event horizon is where two versions of reality diverge. One where return seems possible, and one where it has already disappeared. Beyond the event horizon, space and time no longer behave as separate dimensions. The distinction that allows direction, choice, and distance begins to collapse. Outside a black hole, movement defines outcome. You approach something, or you move away from it. Inside, outcome no longer depends on motion. Every possible future points inward. What changes here is subtle, but absolute. The flow that once allowed delay, decision, and deviation compresses into a single progression. The future becomes narrow, not metaphorically, structurally. Moments no longer open into options, they close into sequence. Events do not unfold across space, they accumulate toward an inevitable resolution. This is why the interior of a black hole cannot be navigated, not because of resistance, but because navigation itself has lost meaning. There is no route to evaluate, no interval to extend, no pause to exploit. What remains is duration moving toward convergence. From within this region, the center is not approached. It is arrived at, not suddenly, not violently, but as the only continuation that time still permits. As collapse continues, the equations keep tightening. Density increases, curvature deepens, intervals shrink. Eventually, the math reaches a point it cannot extend beyond. Values explode, quantities lose scale, prediction gives way to divergence. This point is labeled the singularity. But the name is deceptive. It suggests a thing, a core, a final object waiting at the center. What it actually marks is the breakdown of description. The singularity is where general relativity stops being usable. Not because reality ends there, but because the framework does. At that scale, space is no longer smooth. Time no longer behaves continuously. Cause and effect lose their familiar order. The equations do not reveal what happens next. They simply fail to continue. This failure is not unexpected. General relativity was never designed to operate at infinite density. It describes gravity as geometry, not as a quantum process. And inside a black hole, gravity is no longer just strong. It dominates everything else. Without a theory that unifies quantum mechanics and gravity, the singularity remains inaccessible, not physically, but conceptually. So the heart of a black hole is not a discovered endpoint. It is a boundary of knowledge, a place where the universe continues to behave in some way, but where our language, our models, and our confidence can no longer follow. What lies beyond that limit is not hidden by darkness. It is hidden by the absence of a theory capable of describing it. At the heart of the black hole, the deepest problem is not gravity. It is information. In physics, information is not abstract. It describes the complete state of a system, every particle, every interaction, every detail that determines what can happen next. According to quantum theory, information cannot simply vanish. It can change form. It can scatter. It can become inaccessible. But it cannot be erased. Black holes challenge this principle directly. When matter falls in, its information appears to be lost to the outside universe. Nothing returns intact. Signals stop. Histories disappear behind the horizon. For a long time, this suggested something radical, that black holes destroy information completely. If true, this would break one of the most fundamental rules of modern physics. The universe would no longer be predictable even in principle. The past would stop determining the future. This conflict became known as the black hole information problem. Later, another possibility emerged. Black holes are not perfectly black. They emit a faint radiation. Over immense spans of time, this radiation allows them to evaporate. The question then sharpened. If a black hole disappears, where does the information go? If it escapes with the radiation, how is it encoded? If it does not, then information truly dies at the center. The problem is unresolved, but its implications are clear. Whatever exists at the heart of a black hole is not just crushing matter. It is forcing the universe to decide whether its own memory is permanent or conditional. As the information problem deepens, attention shifts away from the center and back toward the boundary. Because the most radical idea does not place the answer at the heart of the black hole. It places it on the edge. The event horizon may not be a passive limit. It may be an active structure, a surface where information is preserved, compressed, and rewritten into a form that no longer resembles what fell in. From the outside, the horizon appears thin, featureless, almost unreal. But mathematically, it behaves like a storage layer, a surface where the interior is fully encoded without being directly accessible. Everything that crosses adds to this encoding: mass, energy, history. Nothing passes through unchanged. Nothing disappears without trace. The black hole begins to resemble a boundary that contains an entire volume within its surface. This idea reshapes the question completely. The heart may not hold information at all. The boundary may. And the interior becomes something stranger, a region whose reality is fully described elsewhere. From this perspective, the black hole is not hiding its contents. It is redistributing them, not across space, but across description. The collapse does not erase the past. It rearranges how the past is allowed to exist. What this suggests is unsettling. The deepest structure of reality may not reside where events happen, but where they are recorded. And if that is true, then the black hole's boundary is not a limit of access, it is a limit of perspective. Once the center loses meaning and the boundary gains structure, a new possibility appears. Not as an answer, but as a consequence. If information is not destroyed, and if collapse does not end description, then the interior may not represent a final state. It may represent a transition. Some models suggest that under extreme compression, the structure of space-time does not terminate. It reorganizes. The collapse continues inward, but the geometry does not close into nothing. It folds, redirects, detaches from the space it came from. In these scenarios, the heart of a black hole is no longer treated as a terminal point, but as a passage into a separate expansion, not an explosion, not a continuation of this universe, a new region of space-time with its own internal flow of time, cut off from its origin by the same boundary that made return impossible. From the outside, this process looks like disappearance. From the inside, it may look like emergence. The laws governing this region would not need to match ours exactly. They would only need to be consistent enough to allow structure to form again. This idea does not claim certainty. It arises from necessity. When equations refuse to end cleanly, they often point toward extension, not termination. If the universe allows collapse, and if it forbids absolute erasure, then something must follow, not as a destination, but as a consequence of pushing reality past the limits it was designed to describe. At the deepest level, the heart of a black hole does not give us an answer. It gives us a limit. Every interpretation points to the same conclusion. Our descriptions stop working before reality does. Whether collapse ends in erasure or opens into something else, the transition itself remains unreachable, not hidden by distance, not sealed by darkness, separated by structure. The black hole does not show us what lies beyond its core. It shows us where explanation loses authority. And in that loss, something becomes clear. The heart of a black hole is not defined by what it contains, but by what it forces us to admit we cannot see. We went looking for the heart of a black hole expecting an answer, a final object, a definitive end, or a hidden beginning. What we found instead was a boundary, not in space, but in understanding. The collapse did not lead us to nothingness. It led us to the edge of what explanation can survive. Whether black holes erase reality or recycle it into something new remains unresolved. But one thing is clear. Black holes are not just places where matter disappears. They are places where certainty does. They remind us that the universe does not promise transparency. It allows observation only up to a point. And beyond that point, reality continues without asking to be understood. The next question is no longer what happens at the center, but what kind of universe creates regions where understanding itself is forced to collapse?